And we have one for y'all today that I can screenshot right here. And say if you're a fan of another streamer called Primeagen, you might have seen him do this interview. But this was a really nice clip that he pulled out of it that got a decent amount of views, actually, one of the higher traffic ones, around abstractions just being bad and how you can author your code better to better introduce that for podcast people. We are continuing our journey through programming abstractions, and on this one I pulled together a interview that the Primeagen put together. He's a popular YouTuber and Rust aficionado, and he is interviewing a game developer. Let me get the name of him to make sure I've got that right. Casey Muratori. I'm not super into game development, so I don't actually know some of these characters, but he's prolific in the industry. And it was great getting to hear his perspective on this subject because game programmers deal with performance problems that us web developers don't typically have to deal with. So, without further ado, we're going to get into why they think maybe abstraction is not something they need to worry about right away. Maybe instead of diagramming before code, it's best to code and then diagram in order to feel out a problem space before you know what the heck you're doing. So let's hit play. I'll go ahead and turn on screen capture. Here we go.
We can also pessimize code. We can do things that make it harder for the CPU to run it for no real reason. Like, just we had two things we could choose to do here, and we arbitrarily somewhat chose this much worse one because of some other weird metrics that I don't necessarily know where they come from, like clean code, that I don't feel like anyone ever proved really made anyone more productive, but I can prove they make the CPU less productive. So it seems like a bad trade. And that was pessimization.
There's this weird thing I think that we all have in our head as programmers, which is, what if I add one more? And I feel like this has created an abstraction like complex among everybody. It's just like, well, we could have tomorrow. It's like, yeah, we will. And when we do, we could consider something different. But for now, I always just do like 1D programming because there's no need. Like, I don't care if we add new things tomorrow. I'll deal with it tomorrow. Today, I just want to make it work and make it nice. And tomorrow, if it really, truly does call for this really abstract concept, then we can do it. But almost always has the abstract concept looked clean on a single line where I could be like .get type or whatever. But the shit behind it is crazy. And the moment you need the change, you're like, I have to burn the whole thing down. I can't remember what I did, and it's completely confusing.
So that thing that you literally just said is one of the biggest things that if we could just stop people from doing it, it would make a huge, huge impact. Because what happens is people, and you know, I think I'm a pretty good programmer, but I've definitely worked with some of great programmers, right? So I've seen what they can do. And so I think I have a pretty good handle on, like, if I was to think of the best programmer I know, what do I think their capabilities are? And this programmer is going to be like way better than the average, like your John Carmacks, those kind of guys.
I know we have one at Netflix. His name is Kevin Lee.
There you go. So you know that guy. You can think of who that guy is, right? And the thing is, when I think about that, I know that even them, don't really have the ability to think through an entire complex programming problem without actually doing the programming. They have to see all of the details before they really get it. And usually they have to do it and then they'll change some stuff after. They're like, oh, I see how that went. Now I'm going to revise what I did because there was a better way. Right?
Oh my goodness, I love this. Keep going.
Do you know what I'm saying?
Yeah.
You see what I'm saying, though, right? Maybe I'm missing the mark here because someone out there is thinking about the best programmer they know, and that's not true. But like literally every best programmer I know, where I looked at that person like, holy crap, this person's amazing. This was true of them. And so the way I think of it, and it's absolutely true for me, because if it's going to be true for them, it's going to be true for me. That's just a given. But I feel it in practice, is that I can't predict the correct code structure for something I haven't done yet. So if, by definition, I'm choosing a particular code path because I think it does something that I want to take advantage of in the future, I almost always tell myself no, because I'm wrong. Not because it wouldn't be great to be able to do that, but because you're wrong. That won't be the design that you actually want when you go to do the thing that you haven't done yet.
Let's go! So, this is so good! No, this is totally true. Oh my goodness.
What happens to me is that, and I still do it today sometimes because the voice doesn't kick in.
I know it doesn't. I do it too. Oh my goodness.
And so every time something I do goes smoothly, it's because I remembered write the damn thing first. That just does literally what you were trying to do. And then you will see after you do that, which only takes like a day or two, right? Because you're not thinking about anything else. You're just writing this little thing that does something fairly simple. And then you will see what the correct design was for that, and you just make some modifications to put that into a nice, simple state, and then you're done. And when the time comes, because it will come, and this is fine, when you decide you need to change it, you just write that one new piece, and you move the design around a little bit to accommodate it. And it goes very smoothly because you're always working with the actual ground truth. You actually have the thing running, so you know whether or not the design works, because it is literally working. Predictive design, except
Disaster.
1 in a million, fails.
First off, this is great talk.
Yeah, that's it. It's not the most profound take, but it's one that hits me pretty hard with stuff that I've been doing recently at Astro. I work with an engineer named Matthew, and at first I was really confused why he was able to fix so many bugs so quickly. And I started pairing with him. And the answer is he just plows through and does not care about the code quality at all. He just makes the worst implementation possible and proves that it works, writes one unit test, and then walks backwards. I started doing that, and all of a sudden, like, everything started working. Tests were actually able to pass instead of spending 2 days to work towards a unit test. You could spend 1 hour, get the unit test, and then walk back for better code quality. And it works out for small scale stuff, because usually people think that you have to sort of diagram the world, but you're not building a world. You're building a very small thing. I'm sure you've dealt with that too, but
Yeah, well, so I think this relates to our conversation about Dan Abramov's code when he was
yeah,
talking about the wet code base, or I forget the title of his talk. But he had that exact example, and I've faced variations of that. I've been the dry guy, making the one abstraction to rule them all, and it was a huge, horrible, complicated mess. I spent a whole bunch of time on it. It was very dry, but I spent a lot of time doing absolutely nothing to the to the core,
yep,
so user-facing features of the product.
yep. And it's hard to tell what is user facing and what isn't when you're doing open source stuff, because it's not the website that you're building like it was when I was building e-commerce sites. It's the API. It is still code that's user
Public
facing.
API is user-facing. Your users are developers, right?
Yeah. So sometimes it
So
is justified, like staring at a computer screen for a half hour, deciding the best name and folder structure for stuff, just for the
yeah,
outside
yeah,
exposed
yeah,
part.
yeah,
That's kind of
yeah.
like Figma, but for developers, is you're writing all these VS Code endpoints. And I use Copilot to validate that stuff too. If Copilot can pick up on the patterns that I'm writing, then that's probably a
Mm,
sign that I designed it pretty well. And then I can just codify it.
mm. Copilot-driven development.
It's pretty
I
good.
like
I
it.
treat it like a
Yes.
junior that's just trying to learn how the heck the thing works. And if it picks up
Yeah.
patterns, that's a better sign.
Yeah. So, one variation of this, by the way, is this concept. I think it came from Sebastian on the React team. And he said basically, if your code is hard to model in TypeScript, it's probably bad code,
Yeah,
because you're adding a whole bunch of like
probably.
crazy random modifier types just because you don't know what this thing you're defining is. And I think that has a nice analogy to this Copilot thing that you're talking about, which is, if it's not a pattern that Copilot sees a lot, then you're probably making it very convoluted,
Yeah.
and maybe that's not the best idea. So I kind of like that. That's a really good point. Not made by either of these guys on in the video that we just watched,
It's
but we're just
not.
adding our own value.
I'm adding my own value. I thought I would sneak it in, because I'm
I
still
was
wary about Copilot. I'm afraid of it,
Yeah.
but for that, it seems really good because it's following.
Yeah. Replit has launched another one that we should try to compare them, because there are definitely things where I've spotted Copilot like
For
making
real.
bad choices. So it's not perfect, but we'll see. I was actually taking notes during the video, so I'll just call it out for listeners and viewers. Oh, did you leave the meeting? Oh, it's all
Oh,
good, right?
what?
I don't know.
I
It
think we're all
says
good.
no. It says you left the Google Meet, so there's no longer the screen that we're sharing.
Oh no,
Um,
I don't know how I did that. No, it's still going. It's
okay, all right. It says here you left, but
You're
I'm
right.
trusting.
that's so weird because it was a background tab. It decided that I lost network connection, but her stream's obviously still going.
Yeah. Okay. Well, so
Oh, it slept it. Oh, good to know.
that's all right. So the 4 things that I noted down was one, Casey had this comment about programming is thinking. Like a lot of the best programmers that he knows don't know what they're writing until uh, they actually write start programming, and then they discover the problem, and then they refine their thinking, and then they code the correct solution. And you can't just like kind of sit down in one shot and waterfall design your way through a problem sometimes, just because you don't know the shape of the problem that you're solving yet. So I really like that one. So that's an argument in favor of. I mean, this whole video is an argument in favor of just like not thinking so much and just kind of cowboy coding.
It's in favor of the cowboy. Absolutely. Like you can refine it later. You can be a refined cowboy, but there's definitely I'm actually an imposter with whiteboards because I don't whiteboard things very often. I'm usually using it for stop motion and teaching, but it's only because I know the mental model. Like it is solidified. And I remember trying to do architecture diagrams for an open source project, and it was always out of date every time because it's pre 1.0 and you just don't know what the shape of it's going to be.
Oh, I did. You can actually automate those things. So actually, one of my first posts on
sure you
Netlify
can.
it was it's like this kind of code explorer thing. You can just automate it. If you go on the Netlify blog
That's
and
very
look for my
cool.
posts, you'll see it. It's part of your like CI/CD process. You can just kind of auto generate an image that represents your code structure. That looks nice. Yeah. So okay, a couple more notes. One, Primeagen was saying, you always feel the temptation to like add one more layer, and that phrasing called back for me to another aphorism that people have about coding, which is you can solve every problem by adding in one more layer of direction, of indirection, right? This is a very common saying. So virtualize everything, make a abstract interface for everything. And I think he's arguing, basically both of them are arguing against it. And I think people don't have a mental model of the cost of abstraction. And I think a lot of things that we're exploring this week or in this series of posts is this idea that there is a cost and it's just hard to quantify. But the values, both the benefits of extraction are unproven and the cost of extraction are real.
Yeah, for sure.
Oh, cool. All right. Any other notes?
I don't think so. The rest of the VOD is, just agreeing with the point, of course. I think we've hit everything in here. And Prime joining us live in the chat to
What's up,
give
Primeagen?
more perspective. Yeah.
I
What's
am
up?
not seeing the chat, by the way. So you're driving here.
Okay.
I'm just in the sort of my box a little here.
Yeah. But the Prime joined right when we started. So appreciate it.
How many layers are we in? We're reacting to a video that's embedded in another video. And then Primeagen's like watching us.
Yes.
You put us on his stream and react to the reaction